Task number 2, TLS. At one point, you would only need a packet capturing tool to read all the chats, emails, and passwords of the users on the network. Example that we had, Wireshark. Was not uncommon for an attacker to set their network card in promiscuous mode, that is, to capture all packets, including those not destined to it. They would later go through all the packet captures and obtain the login credentials of unsuspecting victims. There was nothing a user could do to prevent their login password from being sent in clear text. Nowadays, it has become uncommon to come across a service that sends login credentials in clear text. In the early 1990s, Netscape Communications recognized the need for secure communications on the World Wide Web, WWW. They eventually developed SSL, Secure Socket Layer, and released SSL 2.0 in 95 as the first public version. In 99, the Internet Engineering Task Force, IETF, developed TLS, Transport Layer Security. Although very similar, TLS 1.0 was an upgrade to SSL 3.0 and offered various improvement security measures. In 2018, TLS was a significant overhaul of its protocol and TLS 1.3 was released. The purpose is not to remember the exact date, but to realize the amount of work and time put into developing the current version of TLS, that is TLS 1.3. Over more than 2 decades, there have been many things to learn from and improve with every version. Like SSL, its predecessor, TLS is a cryptographic protocol operating on the OSI model's transport layer. It allows secure communication between a client and a server over an insecure network. By secure, we refer to confidentiality and integrity. TLS ensures that no one can read or modify the exchange data. Please take a minute to think about what it would be like to do online shopping, online banking, or even online messaging and mail without being able to guarantee the confidentiality and integrity of the network packets. Without TLS, we would be unable to use the internet for many applications that are now part of our daily routine. Nowadays, tens of protocols have received security upgrades with the simple addition of TLS. Examples include HTTP, DNS, MQTT, and SIP, which have become HTTPS.DNS over TLS, MQTTS, and SIPS, where the appended S stands for secure due to the use of SSL/TLS. In the following task, we will visit HTTPS, SMTPS, POP3S, and IMAP-S. So basically SSL, TLS, same transport security protocol, but with different versions, right? SSL is the older one, the initial one, and then TLS is basically the current one. Technical background. We will not discuss the TLS handshake. However, if you are curious, you can check the Network Security Protocols room. We'll give a general overview of how TLS is set up and used. Let's check this out until this will finish loading. The first step for every server or client that needs to identify itself is to get a signed TLS certificate. So basically, in order to ensure that we have secure traffic, we need a TLS certificate installed. Generally, the server administrator creates a certificate, sign the request CSR, and submits it to a certificate authority, CA. The CA verifies the CSR and issues a digital certificate. Once this signed certificate is received, it can be used to identify the server or the client to others who can confirm the validity of the signature. For a host to confirm the validity of a signed certificate, the certificates of the signed authorities need to be installed on the host. In the non-digital world, this is similar to recognizing the stamps of various authorities. The screenshot below shows the trusted authorities installed in a web browser. So basically, you can see here the default trust for these certificates, right? Basically, these certificates, right? And in these certificates, the specific ones. Generally speaking, Getting a certificate signed requires paying an annual fee. However, Let's Encrypt allows you to get your certificate signed for free. Finally, we should mention that some users opt to create a self-signed certificate. The self-signed certificate cannot prove the service authenticity as no third party has confirmed it. So, as you can see here, Let's Encrypt, encryption for everybody, a non-profit providing free TLS certificates to more than 700 million websites. Answer the questions below. What is the protocol name that TLS upgraded and built upon? SSL. Which type of certificates could not be used to confirm the authenticity of a server? That's a self-signed certificate. Perfect. Now, Let's Encrypt. We saw that, and now you unlocked a streak freeze. That's just something. All right, so as you see, we have in the network security protocols, we have this room. Learn about secure network protocols at a different layer of the OSI model. So basically in here, you can see the application layer, the presentation and session, and then network. So they are just, I see they choose random protocols, and it's a medium room. So basically this room is recommended by TryHackMe if you want to learn more about TLS, and more specifically TLS handshake. How TLS is it is done. Awesome.